Okay, so we have some more identities which we are going to use mostly in factorizations. Okay, so let's see. Suppose we have x plus a, linear in x, and this a is any constant. When we multiply with x plus b, that will give us x square plus a plus b times of x plus ab. This is one of the very important identity that we are going to use in factorization. Okay, so here which we can get this result by just simple multiplication of this with this one, and after simplification just check how we can get this. X multiply with x means x square, and this x with b is what? X times b, and further a into x and a into b, right? So over here from this middle term we can find that x is common, so we can write this as x square plus a plus b times of x plus ab, right? So here if you're taking x common, then this will come b plus a and a plus b both are same. Okay, so this result will use while we'll do the factorization. We'll only splitting the middle term method of factorization, there will use this identity, so mark it. Okay, next one is, in this we have four variation. In place of addition, if we have subtraction in either of the place or subtraction both of this place also, we can have this result, or we can just understand this process and we can use this. Okay, for example, suppose if I'm asking let's say x minus a times x plus b, or if I'm asking let's say x plus b times of x minus b, or x plus a times x minus b, or x minus a times x minus b. Then we can simply write, when we have, see, as the coefficient of x is same means first term will come x square, right? And when we look into this, here minus a, this is plus b, so we can write this as minus a plus b times of x, and the product of negative a and b is what? Negative ab. Okay, and over here we can find this as x square plus a minus b times of x minus ab, right? This one we can write this as x square plus minus a minus b times of x plus ab, because minus a into minus a is plus ab, and over here we can take minus common, so this will give us x square minus of a plus b times of x plus ab. So this is also going to be used very often in factorization. This one is very important. Okay, so these are the identities that we can use in finding the values as well of something which we have given. Let's say suppose we have given 4x minus 3 and we have given 4x minus 5. So we can go for multiplication by using the identity we can find that this is of what format? This format, right? So we can consider this as a, or this as y, then this will be y minus 3 and this is y minus 5. So we can write this as what? First y square. So let me make it simpler first. So what I'm considering is this as y. Okay, y is equal to 4x, then this will become, this expression will become what? Y minus 3 times of y minus 5, which will be equal to y square minus of 3 plus 5 times of y plus 5 3 is 15, right? So this is y square minus 8y plus 15. but we have y which is 4x. If we are substituting y is equal to 4x, then this will become 4x whole power 2 minus 8 times of 4x plus 15, which equals 16x square minus 32x plus 15. So this way we can use the identity to solve this kind of products. Find the product using identity. Find the product using identity. So let's say we have given 5x square minus 3 and then 5x square plus 7. This is the first question. Second question, we have given 4y cube plus 3 and then we have 4y cube plus 5. So find the product using identities. So we can find that this is what this first number is same, right? So this is of what form? X minus a x plus b form, right? So we can consider this 5x square as any other variable y. Then this will become y minus 3 times of y plus 7, right? And we can easily find the product of this as y square plus minus 3 plus 7 times of y minus 7 3 is 21. So this will give us y square plus 4y minus 21, and now substitute back the value of y, which is 5x square. So 5x square power 2 plus 4 times of 5x square minus 21. So this will give us 5 square is 25 and x square power 2 is x power 4, right? So this is 5x to power 4 plus 20x square minus 21. Like this we can solve this also. We can find these two are same, so we can consider this as 4y cube is equal to x. Then this will become x plus 3 and this is x plus 5. So by using the identity we can write it as x square plus 3 plus 5 times x plus 15. So this is x square plus 8x plus 15. Now substitute back the value of x, which is 4y cube. So 4y power 3 whole power 2 plus 8 times 4y power 3 plus 15. So this is 4 square means 16, y power 3 power 2 means 3 to the 6, right? So 16 y power 6 plus 32 y power 3 plus 15. So this is the way we can use this identity and find this kind of product. Okay, now suppose if I'm asking find the product of like x plus a times x plus b times x plus c, then how can we go for the product of this one? How can we go for finding the product of this one? So first thing, we can consider this 2 as usual that we have done before. So this will become what? X square plus a plus b times of x plus ab, and then that result we are going to multiply with the next one, right? So once we further multiply this, we'll get this as this is going to multiply with both of this term. So this is x cube plus x square times c, and then this is going to multiply with this, means this is a plus b times of x square, and then further this is a plus b times of x times of c, and then abx plus abc. Now if you further simplify this, you will find this as x cube plus, here also this is x square c and this is a plus b times of x square. If I'm taking x square common in both, then this will become what? a plus b plus c times of x square. Now further we can find that this is x and this is also x, so we can write this as ac plus bc. This c I'm multiplying with this as well as this, right? So that will give us what? AC plus BC, right? Times of x plus ABX plus ABC. Now further we can think of x as a common in this two. Once we are taking common, this will be reduced to x cube plus a plus b plus c times of x square plus AC plus BC plus AB times of x plus ABC. So by understanding this one, we can go for the generalization. If we have n numbers of multiplication over here, means some finite numbers of binomials in linear x, then how we can go for this? So here we can find one thing. If we have in this product the coefficient of x is 1, right? So over here x 3 times means the leading term will come as the x power 3. When we are multiplying 2 times, the leading term comes x to power 2, right? When we are multiplying 3 times means leading term is coming as x to power 3, right? And the second term is what? The power is going to reduce. See, for the product of 2, we are getting x square, then x and then constant, right? So the x square coefficient is 1. Now the coefficient of x is what? The sum of these number. And the last term is the product of the 2 number, right? So if you see, and the product of these 3, we can find that the leading term is x cube and then the power of x is reducing to x square, then x and then constant. So we can find that the x square coefficient is nothing but the sum of these constant, and x coefficient is what? The product of the sum of the product of 2 constant at a time, means AB, then AC and then BC, sum of these things, and at last the product of all this constant, right? So one of the very important result is, suppose we have given a minus b whole square and then b minus a square and then this is b minus c square and then c minus a square. So once we simplify this, after simplification by using a minus b whole square, we'll get one result. That result is very, very important. So let's try to simplify this. What we'll get? First, a minus b whole square is a square plus b square minus 2ab, and second one is what? B square plus c square minus 2bc. Third one is c square plus a square minus 2ca. So we'll find that a square 2 times, b square 3 times, c square 2 times. So that will give us 2a square 2b square 2ca square. And next one is 2ab 2bc and 2ca, then minus 2ab minus 2bc minus 2ca. So throughout all of this term we have 2 common in all of this. So if I'm taking 2 common, this will become a square plus b square plus c square minus ab minus bc minus ca. So this is equal to what? 2 times of a square plus b square minus c square minus ab minus bc minus ca. This is the value of a minus b whole square plus b minus c whole square plus c minus a whole square. This can be written further as, this 2 is right in multiplication. If I'm taking to the left, that will goes in 1 over 2. So 1 over 2 times of a minus b whole square plus b minus c whole square plus c minus a whole square is equal to what? A square plus b square plus c square minus ab minus bc minus ca. This result is very, very important result when we deal with the identities of power 3. So just keep a note of this, take a note of this. Okay, we'll use this when we are going to derive some of the result. Okay, so this is very, very important identity. Okay, so now let's move to the identities of power 3. So till now I have discussed most of the identities based on the power 2, the sum or difference of 2 numbers squares. Okay, so one more thing is there. If we have sum of 3 numbers square, then how we can go for finding that? Or we have 4 number sums square. So let's see those examples first before moving to the power 3 identities. So suppose we have given a plus b plus c whole power 2. Then this will become equal to what? A square plus b square plus c square plus 2ab plus 2bc plus 2ca. Right. So this is the basic identity. This can be written in either way also, a square plus b square plus c square. You can take 2 common and write ab plus bc plus ca. Right. So this is one of the identity that we need to remember. How we can get this? So very simple. We can consider this as a plus b plus c whole power 2. Whole power 2. We can break this as a plus b as any other variable, let's say x. Then this will become x plus c whole square, and we know this result, right? I'm taking a plus b is equal to x. Then a plus b plus c will be x plus c whole square, and then you can use the identity x square plus c square plus 2xc. Now substitute x place a plus b, will get this as a plus b whole square plus c square plus 2 times of a plus b times of c. So once you expand this, this will become a square plus b square plus 2 ab then plus c square plus 2ac plus 2bc. Now rearrange this, will get it as a square plus b square plus c square plus 2ab plus 2bc plus 2a. So this way we can derive these identities, okay? But the thing is, we need to remember this or this one, okay? So we have like some more derived result on this also by connecting some of the non-identity, like I have discussed just before one identity, right? So we can connect this that identity with this, because we have gotten the value of a square plus b square plus c square minus ab minus bc minus ca, right? So with the help of that, we can convert this into some other standard form also, okay? That we'll see, okay? So first let's try to solve a couple of examples based on this identity, and then we'll go for some derived result on this. So this is the standard identity, or we have given a over here plus minus anything like b and minus c also. So we can get this by just simply writing this as a plus b, and in place of minus c we can write it as plus minus a. We can replace like this, and this is going to fit into this form, and then we can use this result, okay? Or the same way we can go for a minus b plus c whole square. So this can be written as a plus minus b plus c whole square, and then we can go with this particular result, and at last we can write this as a minus b minus c whole power 2, which is going to be a plus minus b plus minus b c and whole power 2. Now by using this result, we can get this as a square plus b square plus c square plus 2ab minus 2bc minus 2ca. So you can try this by yourself. Once you expand this, you will get this result after simplification, right? So this will become a square plus b square plus c square minus 2ab minus 2bc and plus 2a, and at last this will become a square plus b square plus c square minus 2ab plus 2bc minus 2ca. So this you can derive by substituting in this given a standard form. This is the standard form, okay? So let's see. Suppose we need to evaluate this. 4x minus 2y plus 1 whole square. or second question, let's say 3 minus p plus 2q whole power 2. Okay, or keep everywhere minus also. So we can simplify this by using the identities. What we can write this, 4x whole square. So we can convert like this simply, 4x plus minus 2y plus 1 whole square. So this is a, b and c. So we can simply use a square plus b square plus c square plus 2ab bc and ca1. Okay, so this is 4x whole square plus minus 2y whole square plus 1 square plus 2 times of 4x times of minus 2y, and then what, plus 2 times of minus 2y times of 1, and then plus 2 times of 1 times of 4x. You'll get this as 16x square, and negative square is positive, so this 2 square is what, 4y square, 1 square is 1. Now 2 for the 2 for the 8 to the 16, and this plus minus is minus 16xy. Now this is minus plus minus 2 to the 4 1 the 4, so minus 4y, and this is 4 to the 8x plus 8x. So this is the simplification of this, and as we can find, there is no like terms, right? So we can always write in the decreasing order of the parts of the variables. So we can write this as x square plus 4y square, then minus 16xy plus 8x minus 4y plus 1. So the writing of this polynomial in a standard form is like, we always try to write the decreasing order of the parts, and also we are giving the preference to the like variables which will come first. Okay, in the alphabetical, that should be written before. Okay, x then y then z, like this type of things. Okay, so you can find this also the same way. So this is do yourself. Now, as I said, the last one, a plus b plus c whole square identity is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. And also we have seen that a square plus b square plus c square minus ab minus bc minus ca is equal to half of a minus b whole square plus b minus c whole square plus c minus whole square. So by combining these two, we can come up with some different result as well. So let's try to look into that one. What I said is this one, a square plus b square plus c square minus ab minus bc minus ca is equal to half times of a minus b whole square plus b minus c whole square plus c minus whole square, right? This is one result we have. And now I was discussing about this, a plus b plus c whole square is equal to a square plus b square plus c square, then plus 2 times of ab plus bc plus ca, right? So if I'm asking you, if I'm just asking, can we use this ab plus bc plus ca from this one? So just look into this. If I'm just not taking this way, I'm just taking this as 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca is equal to a minus b whole square, b minus c whole square plus c minus a whole square. So from that we can find the 2ab plus 2bc plus 2ca value. So just look into this one. From this one, if I'm just taking this as 2 times of a plus 2 times of b plus 2c square minus 2ab minus 2bc minus 2ca is equal to what? A minus b whole square plus b minus c whole square plus c minus whole square, right? So if I just want to find the value of this ab plus bc plus ca, I'm just taking this to the right side and this all to the left. What will get then? 2a square plus 2b square plus 2c square minus of a minus b whole square minus b minus c whole square minus c minus a whole square is equal to 2ab plus 2bc plus 2ca. So if in this identity, if I'm substituting in place of 2ab, 2bc, 2ca, this one, what value will get? Let's try to look into this one. A plus b plus c whole square is equal to a square plus b square plus c square, and this 2ab, 2bc, 2ca, in place of that I'm using this one, 2a square plus 2b square plus 2c square minus a minus b whole square minus b minus c whole square minus c minus a whole square. That is going to give us a square to a square, 3a square plus 3b square plus 3c square minus a minus b whole square minus b minus c whole square minus c minus a whole square. Right? Right? Right or not? And then we can find that if I'm taking this whole thing to the left, that will give us what? A plus b plus c whole square. So if I'm taking this whole part to the left, that will give us a plus b plus c whole square, and then plus a minus b whole square, then plus b minus c whole square plus c minus a whole square is equal to what? 3 times of a square plus 3 times of b square plus 3 times of c square. Right? So this is also one of the result. This all manipulation we need to learn by combining the identities in order to solve some of the questions based on the polynomial. Okay, so we can understand the way we can generalize some more result from the non-identities. Okay, so here this is what? Sum of a square of 3 numbers plus the sum of the difference of sum of the squares of the difference of the 2 numbers is equal to what? 3 times the sum of the 3 squares of 3 numbers. This is what we can take 3 as common. A square plus b square plus c square. Okay. So this derived result we may use in problem solving. So just try to understand the interpretation, how we are using the non-result to get some of the new result. Okay, so no need of remembering all kind of this derived result. The standard result you need to remember, like this kind of result is a standard result that need to be remembered. Okay, now now we'll move to the identity based on power 3, either power of sum of 2 numbers, power 3 of sum of 2 number, or power 3 of difference of 2 number, or might be the sum of the cube of any 2 numbers or difference of cube of any 2 number. So let me just start with the first one. Suppose we have given 2 number a and b. So if we are adding a and b at power 3, that is equal to cube of first number plus cube of second number plus 3 times of square of first times second number plus 3 times of ab square. Okay, or we can write this also as in this way also, a cube plus b cube plus 3ab times of a plus b, both result. You can derive this result by writing a plus b whole power 3 as a plus b whole square times of a plus b, and by using the a plus b whole square you will get the first product and then multiply. You can check this like this. A plus b whole power 3 is what? We can write it as a plus b whole square times of a plus b. Base same, power will be added, right? So 2 plus 1 will be 3. Now we know this result, right? This is a square plus b square plus 2ab. Now this trinomial is going to multiply with this binomial. So this a square multiplied by a plus b, and then b square multiplied by a plus b, and then 2ab multiplied by a plus b. Further, when we are expanding this, we'll get this as a cube plus a square b, then b square a plus b cube. Right, see, a square into a is a cube, a square into b is a square b square into a is b square a, b square into b is b cube, and then 2ab into a means 2a square b, then 2ab into b means b square, 2ab square. Now looking for the like terms. So the like terms are a square b and 2ab square, right? So the sum of these two is 3ab square. So we'll get this as a cube plus b cube plus 3a square b, and the sum of b square a and 2ab square is 3ab square, because b square a and a square b, b square a and ab square both are same by the commutativity of multiplication, right? So this way we can get this result, and from this you can find that 3ab is common in both of this. So if we take 3ab common, then this will become a cube plus b cube plus 3ab times of a plus b. So we need to remember this result. So this is the first identity based on part 3. So the second one is, instead of addition, if we have subtraction, so that also we can derive by interchanging this plus with minus. So let's see how we can go for this result. So second identity is a minus b whole power 3 is equal to what? A cube minus b cube, then minus 3a square b plus 3ab square, or this we can write it as a cube minus b cube minus 3ab times of a minus b. Okay, this can be derived in the same way, either a minus b whole square times of a minus b, or we can just use this result, interchange this minus with plus, like a minus b can be written as a plus minus b whole power 3, and then we can substitute in this formula. So wherever we have b, there we need to substitute minus b, and odd power of minus will give minus. So we'll get this result as, over here you can see, a cube plus minus b cube. I'm just substituting in this a plus b identity. Okay, and then what? Plus 3a square times of b. In place of b we have minus b, right? And then last one is what? 3a minus b whole square. So this will give us a cube, and minus b power 3 is minus b cube, minus into plus is minus, so this is minus b cube, and this is what? Minus plus minus 3a square b, and over here b is minus, and a square of minus is what? Plus, right? So this will become 3ab square, right? Or in this we can take 3ab common, so the other version of this is going to be a cube minus b cube minus 3ab taken common. So what is left? A, and here what is left? B. We want plus, so we have taken minus, so minus minus will be plus, so we need to keep minus over here. So this way we can derive this identity, a minus b whole power 3 is equal to what? A cube minus b cube minus 3ab times of a minus b. So these are the basic identity that must remember. Okay, derived identity, if you are understanding and practicing more questions, then you will able to remember those identity as well. But the primary thing is to remember these basic identities in power 3 as well as part 2. Okay, now let's try to solve some question based on this, and then we'll go for the derived identity from this part 3. So try to find the value using identity. Evaluate using identity. So let's say I want the value of 1002 power 3. 1002 power 3. First question. And next question is, let's say 998 power 3. Try to evaluate these two using the identities. So here we have power 3. So 1002 can be written as sum of the two number, right? Sum of the two numbers. So we can write this 1002 as 1000 plus 2 whole power 3, right? So now this become a plus b whole power 3. So we can use the identity of a plus b whole power 3. So that will give us 1000 power 3 plus 2 power 3 plus 3 times of 1000 times of 2, right, plus 1000 plus 2 means a cube plus b cube plus 3ab times of a plus b. So if we are going to take the cube of this, so as 1000 cube is what? 1 cube is 1, and then for 3 0 the cube will come 3 times. I mean 9 zeros will come, right? So 1 2 3 4 5 6 7 8 9, and this is 8, and this will become what? 3 to the 600 times of 1002. Now just multiply this one. So once we multiply this, 6 2 times is 12, 0 times 6 is 0, and 6 times of 1 is 6. After that 2 more zeros, right? So now add this value. So this is what sum of these two is 601208, and here 1, after that 90. So once we add this over here, 3 and 6 digit, right? So just add all of these are zeros, means up to 6 digit the same number will come, 601208, and after 6 digit 246 over here we have 0001. So this is our answer. Okay, so this second question can be done by like same way. We can write this 9980 as 1000 minus 2, because finding the cube of this is like very big number. Multiplication of 998 with 9988, again that result we need to multiply. That multiplication is typical and it will take time. But if we are able to write this as 1100 or something, so the multiplication of that number or a square or power of 3 of those number will be much easy. You can see this example, right? So we can write this as 1000 minus 2 whole power 3. Now with the identity, the same way we can write this as, like if we can't remember the exact identity of a minus b whole power 3, the smart way is to just write this as plus minus 2, right? Because plus minus will become minus only, right? But this is fitted into the formula a plus b whole cube, and in that place, in place of a we need to keep 1000, in place of b we need to keep minus 2. Okay, so that will give us what? 1000 power 3 plus minus 2 power 3 plus 3 times of 1000 times of minus 2, and the sum of these two means 1000 plus minus 2, right? So this is what? 1/90, I mean 369, and minus 2 power 3 is what? Minus 2 power 3, odd power means negative, odd power is negative, so this will be negative. 2 power 3 means 8, negative 8 plus is what? Negative 8, right? So plus minus minus, so this is negative 8. Multiplication of 3 with 2 is 6, and this minus plus is minus, so this is minus 6000 times 1000 minus 2 is what? 998, right? So now further write this one, 1 triple 0 triple 0 triple 0 over here, right? And this is 8, multiply these two. So once we multiply, 6 8 times is 48, remainder 4, 6 9s are 54, 4 is 58, and then 6 9s are 54 and 5 is 59. Okay, 6 8 times 48, remainder 4, 6 9 times 54 plus 4 is 58, remainder 5, 6 9s are 54 and 5 is 59, and after that we have 3 0, so 3 0 over here. Now this both are in negative, so we can just add this negative integers, so we'll get this as negative 598808. Okay, now we need to just subtract from this one, as these all are zeros, so this will take carries from here, this 9, then this will become 10 like this. So this is 10, 10 minus 8 is 2. Now this is 9 minus 0 is 9, this is 9 minus 0 is 9, this is 9 minus 8 is 1, this is 9 minus 8 is 1, this is 9 minus 9 is 0, this is 9 minus 5 is 4, right? How many digits? 3 and 4 7, so 2 more zeros and 1, right? Count the digit, 3 6 9 and 1 10, 3 6 9 and 10. I think this 1 0 won't come. 1 0. See over here, 10 minus 8 is 2, 9 minus 0 is 9, 9 minus 0 is 9, 9 minus 8 is 1, 9 minus 8 is 1, 9 minus 9 is 0, 9 minus 5 is 4, so this is now, this is 9, so 9 minus 5 is 4, means this is last is 9, this is 9, so 940111992. Okay, so this way we can use these identities for finding the cube of the values like this. This is just for practicing the identities. Okay, so for like CBSE exam 9th grade level, this kind of question can be asked. Okay, now let's try to solve one more question based on this identities, and then we'll go for the derivations of some more derived identities. Evaluate. Three x plus 4y power 3. Second one is, let's say, x plus x minus 2 whole power 3. Simple example, right? So this can be easily found by using this x plus minus 2 whole power 3, and then we can expand it, right? So we can write this as x cube plus minus 2 power 3 plus 3 times of x square times of minus 2 plus 3 times of x times of minus 2 square, right? So this is x cube and this is minus 2 power 3 is minus 8 times of plus is minus 8. Then minus plus minus 3 to the 6x square, and then minus 2 square is plus 4, 4 3 is 12, so plus 12x. Now we need to write this is a polynomial in variable x, so always try to write the polynomial in decreasing order of the powers. So here x power 3, then minus 6x square, then plus x minus 8. So the same way we can find this question also, 3x plus 4y, so we can write this as 3x power 3 plus 4y power 3 plus 3 times of 3x power 2 times of 4y, and then plus 3 times of 3x times of 4y power 2. So this is power 3 for both of this number 3 as well as x. So 3 power 3 means 27 times of x power 3. 4 power 3 means 4 into 4 into 4, which is 64. So this is 64 y power 3. Then plus 3 3s are 9. So here 3x square. 3 square means 9. 9 3s are 27. 27 4 times 108. 108 x square y. And then next one is 4 square is 16 and 3 3s are 9. 16 9s are 144. 144 x y power 2. Right. So this is the expansion of this by using the identity. Okay, I hope this is clear. Now we'll move to derive some of the derived identities on part 3. The first derived identity is AQ plus BQ is equal to A plus B times of A square minus AB plus B square, or plus B square minus AB. This is the first derived identity, and the second derived identity is this one. AQ minus BQ is equal to A minus B times of A square plus AB plus B square. So these derived identities are very useful in polynomials, coefficients and root relationship, or the formation of the polynomial for the given roots or zeros. Okay, the formation of quadratic polynomials for the given roots. Right, so that is going to be the next. After this, I'll upload 2 more videos based on the factorization one, and then few more questions on factor and remainder theorem. After that, we'll upload the video based on the relationship between the coefficient and the roots of polynomials. So there, this will be very very useful. Now see how we can derive this result. First thing is, this is AQ plus BQ. So we need to just think of what identity we already know. What identity we already know? We know this identity. A plus B whole power 3 is equal to AQ plus BQ plus 3 AB times of A plus B. Right. 3 AB times of A plus B. Now just think of, we want the value of AQ BQ, so what additional terms are there? Try to switch those terms to the other side of this equation. Once we do that, we'll get this as A plus B whole power 3. This is in plus, goes to other side, minus 3AB times of A plus B is equal to AQ plus BQ. Right. So what I have done, this is the non-identities that we have, and we want to derive this result. We'll derive this, and then in future we'll use this directly. So what I did is, I wrote down the identity which is non for the sum power 3 of the sum of 2 number, which is A plus B whole power 3 is A power 3 plus B power 3 plus 3AB times of A plus B. We want the value of AQ plus BQ, so I'm just keeping this on this side, and the rest of the term I'm taking to the other side of the equal to symbol. So plus goes to minus. Now you can find one thing over here. This is having A plus B whole power 3. And this is having A plus B whole power 1. So over here we can find that A plus B is common in both or not. We can write this as A plus B whole power 2 times of A plus B or not. And this is 3AB times of A plus B, which is equal to AQ plus BQ. Now we can find that this A plus B is common. So we can take this A plus B common. Then we left with A plus B whole square minus 3AB is equal to AQ plus BQ. AQ plus BQ. Now while we are deriving this result, during this derivation we got something which is also very important. This is also very important in like problems related with the roots of the quadratic polynomials, sum of the root and product of the root based questions, the relationship between the roots and coefficient. So this is halfway of the derivation, but this is also one of the results that need to be remembered. So now when we are going to expand this a plus b whole square, that will give us what? A square plus b square plus 2ab, and this is minus 3ab. A plus b times of this is equal to AQ plus BQ. Right, now this plus 2ab minus 3ab, if we are subtracting this, that will give us what? Minus ab. So this becomes a plus b times of a square plus b square minus ab times, okay, is equal to AQ plus BQ, which is the result we were trying to derive. Right, AQ plus BQ is a plus b times of a square minus ab plus b square. Order does not matter, whether we can write this as a square plus b square minus ab or this one, both are same only. Right. So but this result is also one of the results that you need to take a note of this. AQ plus BQ is equal to what? A plus b times of a plus b whole square minus 3ab. Okay. The same way, when we are going to derive this result, we'll also come up with the same type of intermediate result also. Like here we have gotten this result. Let's try to derive this. We want AQ minus BQ. So this is the difference of the cube of two numbers that we can obtain by finding the cube of the difference of two numbers. Here we got this sum of the cube of two numbers by using the cube of sum of the two numbers, right? So here this is the difference of cube of two numbers, so we need to go for the cube of difference of two numbers identity. So we know this one, a minus b whole power 3 is equal to AQ minus BQ minus 3AB times of a minus b. We know this, right? What we want AQ minus BQ. So what additional terms are there, we'll try to take to the other side. So that will give us a minus b whole power 3 on the left, and I'm switching this to the from right to left, that minus goes to plus. 3ab times of a minus b is equal to AQ minus BQ. Right. So the same way we got over here one thing, a minus b whole power 3. So we can take this a minus b common, then we left with a minus b whole square plus 3ab, which is equal to AQ minus BQ, which is equal to what? AQ minus BQ. Right. Okay. Furthermore, we can expand this. We'll get this as a minus b times of a square plus b square minus 2ab plus 3ab, which is equal to AQ minus BQ. And this minus 2ab plus 3ab is going to give us plus ab. So a square plus b square plus ab times of a minus b is equal to AQ minus BQ. Okay, so over here we got this intermediate result, but this result we are not going to use as frequently as this one. So this is very important, very important. Okay, so this way we can derive these identities now, but in future we need to remember these identities, which is both of these are very important, very important. Okay, furthermore we'll derive some more identities based on this. Okay.